The Southeast Trawl Fishery is the largest supplier of seafood to Australian markets, providing nearly 80% of all fresh fish consumed in the country. The $70 million fishery operates from ports in New South Wales, Victoria, Tasmania and South Australia, landing around 30,000 tonnes of seafood annually. The fleet of around 100 vessels consists mainly of diesel-powered otter-board demersal trawlers, around 20 to 25 metres in length. The fishery is managed by the Australian Fisheries Management Authority, or AFMA. In 1992, an individual transferable quota system was introduced for the 16 key commercial species, but there are also controls, including a minimum mesh size of 90 millimetres and a limit on vessel numbers. Overall, around 100 species landed by Southeast trawlers are sold to seafood consumers in Australia and abroad. While most is sold through Sydney and Melbourne markets, significant export markets exist for blue grenadier, orange roughy and school whiting. The fishery directly employs over 2,500 fishers and provides the economic backbone to coastal towns such as Eden, Lakes Entrance, Portland and Devonport. When trawling, commercial seafood species are often caught in association with lower value non-target species known as bycatch. Some bycatch species may be retained for sale and are referred to as byproduct. Others may be discarded at sea and are sometimes referred to as discards. These discards may be thrown away for reasons including unsuitability for consumption or quota restrictions. Other edible species may simply be unprofitable to land due to market forces. Stakeholders, including industry and conservation groups, have expressed concern over the practice of discarding and its effects on marine ecosystems. Globally, it is estimated that for every tonne of seafood consumed, a further 250 kilograms of marine life is discarded. Two years ago, the Southeast Trawl Fishing Industry Association, or SETFIA, joined forces with researchers and gear technologists from 4 states to investigate ways of reducing unwanted bycatch. The multidiscipline project team included commercial fishers and net makers and scientists from Marine and Freshwater Resources Institute, New South Wales Fisheries, the CSIRO, the Australian Maritime College and CNET. The $1 million trawl bycatch reduction project was largely funded by the Fisheries Research and Development Corporation. We asked Ian Nucky, Principal Investigator with MAFRE, about how this collaborative project began.
From the outset, this project's involved a collaborative approach between industry and scientists that's achieved very good outputs. We've not only involved industry at the very beginning from scoping the objectives and the design of the work, but we've also undertaken all the research on industry vessels. This has had some real benefits for all concerned. Most notably, we've achieved the levels of bycatch reduction we set out to do, but also we've done it by using simple gear with practical solutions that the fishermen are happy to adopt.
It was decided early on that the project should represent the interests of participants in all areas of the fishery. Portland vessel the Zeehan, owned by the Toba family, was selected for fieldwork in the western region, and the Shelley H, owned by the Jubb family of Bermagui, was selected for work in the eastern region. Industry skippers and crews have provided invaluable contributions to gear development and data collection aboard the vessels. All commercial landings of quota species were leased from vessel quotas, as occurs under normal fishing conditions. Sales of fish captured during the project were used to pay transport and marketing costs, and to partially fund the charter of vessels for fieldwork. The project coincided with the release of AFMA's Bycatch Action Plan for the Southeast Trawl Fishery. The plan outlined ways in which the operators could reduce unwanted bycatch, including the use of more selective gear. In accordance with the principles of Ecologically Sustainable Development, or ESD, Commonwealth legislation will soon require commercial fisheries to demonstrate efforts towards sustainability. This will help to ensure the future of Australia's unique marine biodiversity and the livelihoods it supports. The research project consisted of three main components. First, a cod end cover experiment was conducted to determine the selectivity of current trawl gear. A study of fish behaviour within trawl gear was then undertaken to determine if behavioural responses would influence the escapement of fish species. Finally, an experimental trouser trawl was developed and used to test a range of cod end configurations to reduce trawl bycatch. Most vessels operate trawls with 90mm diamond mesh cod ends. Initially, the project team set out to determine how many fish actually escape from this type of gear. A fine mesh cover was placed around the cod end using PVC hoops to separate the cover from the cod end. The cover caught fish as they escaped from the cod end. The catches from the cod end and the cover were then sorted separately to clearly show what was retained and what escaped. The results were surprising. About 50% of the number of fish entering the trawl escaped through the cod end mesh. Usually, the fish that escaped were small species of no commercial value, including whiptails, cardinal fish and cucumber fish. Sometimes, however, juvenile commercial species also escaped, providing an added incentive to improve selectivity for the benefit of next year's catch. With these encouraging results, and based on other scientific work, it was decided that the cod end was the best area within the trawl to improve trawl selectivity. Researchers from the Australian Maritime College developed a specialised low-light underwater video to study fish behaviour inside trawls. The system provided pictures down to depths of 600 metres in different areas of the net. Of particular interest is the way that fish respond to the capture process. By taking note of how and where fish attempt to escape from trawls, we can redesign gear to allow the escape of unwanted fish while retaining important commercial species. Here in slow motion, we see unwanted fish escaping through open meshes in the cod end. To measure fish escapement from cod ends, the project team developed a double-ended trawl known as the trouser trawl. The trouser trawl consists of a regular commercial trawl modified to have two cod ends instead of one. A separator panel was fitted to ensure that fish in the trawl had equal probability of entering either cod end. Researchers compared the size and species composition of the catch from a range of modified cod ends against the 90mm diamond cod ends typically used by industry. Modifications included larger diamond mesh and square mesh cod ends. Before field trials of the trouser trawl commenced, the design was tested in the flume tank at the AMC. Hundreds of experimental shots were then conducted on board the vessels for a range of depths and target species. Species captured in each cod end were sorted, weighed and measured. By compiling data from all of the shots, the team has provided a clear picture of what is retained and what escapes from each mesh type. Five modified cod ends were trialled alongside the standard 90mm diamond mesh cod end. 90, 102 and 110mm square and 102 and 110mm diamond mesh cod ends were all tested in the trouser trawl. Let's have a look at some of the results. In deeper waters in the east, 90mm square mesh cod ends reduced the number of discards by nearly 60%. With less than 10% reduction in commercial catch weight. The bin on the left shows the discarded component of the catch from a 90mm square mesh cod end, while the bin on the right shows what is discarded from a comparative shot using 90mm diamond mesh. Similar results were obtained in the west, where a 110mm mesh cod end caught about 40% less discards than 90mm diamond mesh, with a negligible reduction in commercial catch. The results gained during this project offer industry some simple and cost-effective solutions to reduce bycatch. Apart from the ecological benefits from improved gear selectivity, there are also potential economic advantages in reducing the unwanted bycatch, including increased fuel efficiency, decreased sorting times, and improved product. Some industry members have already adopted gear modifications that reduce discarding in the fishery. To further promote this uptake, the FRDC has funded an industry-based extension project in the southeast and Great Australian Bight trawl fisheries. A hands-on team of fishermen will champion efforts in bycatch reduction and deliver information to industry to assist them to make informed decisions on bycatch reduction. Because these fisheries target different species on a range of fishing grounds, there will need to be different cod end options made available to reduce discarding. Fishers may then adopt certain cod ends in particular areas or times of the year to minimise discarding while retaining their commercial catch. Industry involvement will be the key to successful bycatch reduction in the fishery, with ongoing support from a large network of scientists and gear technologists. Trawl fisheries in southeastern Australia now have a good opportunity to be proactive in reducing their unwanted catch. By continually striving for improved fishing methods, the fishery can look forward to a truly ecologically and economically sustainable future.